Okay. Okay. Good evening, all. Now, in last lecture, we have finished our first section. Now, from today's lecture onwards, we are starting the second section. And from that second section, our first chapter will be heat treatment of the steels. Before we start the actual chapter, first we will go through the syllabus content for this chapter. Now, this chapter will be divided in the three different categories, or in short, you can say that. First, in the first part, we are going to deal with the what is the meaning of the heat treatment, what are the objectives of the heat treatment, then general steps which are present in performance of the while performing the heat treatment. You have to follow certain general steps. Which are that steps? That steps we are going to learn in the first part. Then TTT and CCT diagram, that is time temperature transformation diagram and continuous cooling transformation diagram for only eutectoid steels. Okay, this uh, okay. Compulsory one question will be there from this part A. You can see that part A. Either they will ask you the concept of heat treatment process along with its objectives and steps, or they will ask you any one diagram. Either they will ask you TTT diagram or CCT diagram. Sometimes they have asked both the diagrams. For eutectoid steels, you have to draw this diagram, TTT diagram and CCT diagram, and you have to show means that curves are there. Sometimes they will ask you whichever different processes we are going to discuss in the part D. These processes, like suppose here annealing process is there, then normalizing process is there, this normalizing process, annealing process, then a hardening, tempering process. These processes you have to plot on these TTT diagrams. Okay, this is very important part from this heat treatment chapter. You have to learn related to this TTT diagram. Then CCT diagram is very much similar to TTT diagram. Then we are going to discuss the different processes, how these heat treatment processes are conducted. For that, in that we are going to deal with the annealing process, then normalizing, hardening, and tempering process. And there are different subtypes are there that we are going to discuss in detail. In this process, what we are going to learn here, why these processes are conducted, means what is the purpose of conducting this process, then how this process is conducted, that is the process. Okay, a procedure or process, then different types, and what are their different applications and limitations for each process, like annealing, normalizing, hardening, tempering. We are going to learn related to their purpose, then procedure or process, then there are different types and there are different applications along with there some limitations that we are going to deal in the part B. Now in this part B, two questions will be there, at least two questions will be asked on this part B. Okay, either they will ask you any one process and you have to write their purpose, then how that process is conducted, then there are different types and applications, or they will ask you their diagrams. Okay, they will ask you their schematic representation, and some common questions will be like this: you have to draw this annealing process curve, or this normalizing process curve, or this hardening and tempering process curve on this TTT diagram. Whichever initial TTT diagram is there, okay, it will remain standard for all remaining steels. Just you have to impose that curve on this TTT diagram. Then how that will be done, for the I will conduct the separate lectures on it. But you have to remember that there will be confirmed fixed question on it. You have to draw this diagram, TTT diagram, CCT diagram, and imposing of these processes, annealing, normalizing, hardening, and tempering processes on that TTT diagram. Okay, this, these means four processes they will ask you for 2 marks each, and 4 diagrams you have to draw. Okay, this question will be compulsory. This question will be there. One question will be there related to the theoretical part from this heat treatment, TTT and CCT combined. One theoretical question from this, one or two theoretical questions from this part B, and one compulsory question related to the drawing. You have to draw that curves, TTT diagram you have to draw, and you have to impose the process, annealing process curve, normalizing process curve, hardening and tempering process curve on that TTT diagram. That one compulsory question will be there, and 2 questions will be there for 6 to 7 marks each on this surface hardening treatment. Okay, in this surface hardening treatment, different types are there. 2 questions will be on this, and one compulsory question will be from this induction hardening or flame hardening. Okay, whichever I am indicating here, induction hardening or flame hardening, one compulsory they will ask. And from remaining types, that is carburizing, nitriding, and carbonitriding, from these 3 types, on one type they will ask you questions. Okay, 2 questions from this part C, 2 questions from part B, and 1 questions from part A. Okay, in this way you will get 5 to 6 questions from this chapter, and it will cover almost 60 to 70% part of the section B can be covered with the help of this one chapter only. Okay, please remember this. It is having very high weightage, and it is throughout. This is very conceptual chapter. Just you have to remember what property changes you are doing. Depending on that, you will be able to recall the temperatures, and you will be able to recall the process also. And we are having one practical on this process also. We are going to perform this annealing, then normalizing, hardening, tempering. All these processes means how the heat treatment process will be carried out in actual practice, that we are going to conduct one practical in our metallurgy lab also. Okay, when we will start actual college, then at that time we will perform that. Okay, then this is the actual syllabus content for this chapter, heat treatment of the steels. Then after discussing the actual syllabus content, what are the prerequisites? Means what are the prerequisites? Means the concepts that you should aware before starting reading of this chapter. It will be related to this remaining will be compulsory. That is the engineering, chemistry, and workshop practices, manufacturing processes. These are the prerequisites for whole metallurgy subject. But for particular this chapter, you should be aware related to the ferrous materials and their different alloys. Okay, in this in your syllabus, we are going to deal with the heat treatment, that we are going to discuss related to only steels. Only steel related heat treatments we are going to deal with. That's why in the you should aware of ferrous materials and their alloys. And in this, you should aware of iron-iron carbide equilibrium diagram. Okay. That is compulsory part. You should aware about that iron-iron carbide equilibrium diagram. For throughout this entire chapter, we are going to take the reference of that iron-iron carbide equilibrium diagram only for taking the temperatures, whichever temperature points will be there, and performing the different processes. We are going to take the reference of that iron-iron carbide equilibrium diagram. Okay, so these are the prerequisites for this heat treatment of the steels. Then in this heat treatment of the steel chapter, now this is the first point. What is the meaning of the heat treatment? Okay, first point will be what is the meaning of heat treatment. In this lecture, we are going to deal with what is the meaning of the heat treatment. Then what are the objectives of the heat treatments, means why this heat treatment is performed or required, and general steps involved in this heat treatment process. Okay, now this part we are going to cover in today's lecture. I will start now. Then first we will start with what is the meaning of this heat treatment process. Okay, now generally this heat treatment process consists, or it includes any heating or cooling operation. It includes any heating or cooling operation, or any sequence of 2 or more heating or cooling operations. Okay, there will be a set of heat. In short, you can say that there will be a set of heating and cooling operations, or set of heating and cooling cycles, and we are applying that to change the properties of that particular material. That will be termed as the heat treatment process. Okay, we are going to apply here any sequence of heating and cooling cycles. Okay, you can apply one heating cycle and one cooling cycle, or you can apply 2 heating cycles, one cooling cycle, like that. there may be variation depending on your need. There may be variation. There may be variation in this, but what initially there will be, or basically there will be one heating cycle and one cooling cycle, and or you can take the two or more heating cycles or two or more cooling cycles also. And what is your ultimate aim here? Your ultimate aim is to change the properties of the material. Change the properties of the material. Now here you will be able to change its physical properties. You can change its chemical properties. You can change its mechanical properties also. Okay, or you can change its microstructure, or you can say that internal structure also with the help of this heat treatment process. Okay, in short, you can say that here we are going to apply heat treatment. It is a process which consists of set of heating and cooling operations to change the properties of the material, or you can say that to change the physical, chemical, and mechanical properties of a material. That will be termed as the heat treatment process. Now here I have taken one reference here. I will explain how this heat treatment process will be conducted. This is the general heat treatment cycle. Now here first step, this is the heating cycle. Here I have mentioned it. One, heating, then two, holding or soaking, and three, cooling. These three steps will be there. These three steps I will explain it in detail, but for your just try to understand the concept what we are doing here. It consists of heating the material to some specific temperature. Here initially we are heating the material to a definite temperature or specific temperature, and at that particular temperature we are holding that sample for a definite period of time. Okay, here this horizontal line, constant temperature, this is the first inclined line, increase in temperature. This is the heating cycle. We are heating the material. Then after that, one horizontal line, we are keeping the temperature constant for a definite period of time. This is the holding cycle. And the last one, we are doing the cooling. From these higher temperatures, we are cooling it up to room temperature, or sometimes we are going to cool it below room temperatures also. Okay, depending on the which properties we need, depending on that, we can select the different rate of the cooling, and we can select the different temperature ranges also. Okay, heat treatment cycle, it consists of first step, heating cycle. Then we are initially heating the material at some specific temperature, then holding at that temperature for some specific period of time, and after that we are cooling it. You can cool it up to room temperature or below room temperature also, depending on that type of the steel, and depending on the property changes you desired or required property changes. So this is the general heat treatment cycle. It consists of heating cycle, then holding time or soaking time, and the cooling time. Okay, and then after this, we will see and discuss why we are conducting this heat treatment process, whichever the steps are there, why we are following this, what is the purpose. Here, our ultimate aim is to change the properties, okay, to change the physical, mechanical, or chemical properties. Then which properties can be changed or which properties can be altered, that is nothing but your objective. Why we are conducting the heat treatment process. Here, ultimately, we want to change the properties according to our desire. Now, the first objective will be sometimes we want to increase, suppose for particular application, you require better hardness, wear resistance, corrosion resistance in that particular steel material. Then you can improve it by performing a definite heat treatment process. Okay, means here that we are going to discuss in the hardening process. In the hardening method, we are going to increase the hardness of that material or hardness of the steel, then wear resistance, abrasion resistance, and cutting ability of the steel. That is the first objective, is to increase hardness, wear resistance, abrasion resistance, and cutting ability of the steels. Now this is achieved by performing the hardening process. That process we are going to discuss in detail in our coming lectures, how that hardening process will be conducted, which steps you have to follow, What are the different types and application that we will discuss in later. Just here, what you have to understand that heat treatment process can be used to increase the hardness of that particular material or particular steel, then wear resistance of that steel, abrasion resistance of that steel, then corrosion resistance, cutting ability of the steel. And sometimes we want to decrease the hardness, or sometimes we want to improve the ductility or toughness in that material. Then here it will come in this, that is to resoften the steel. Okay, to resoften the steel after it has been hardened. Okay, sometimes some processes or hardening processes or some cold working operations will result in the very high hardness. Means that material can get break during the practical applications or practical use. Then it requires to increase the ductility in that material, and that can be achieved by performing this heat treatment process. That is, you can perform annealing or normalizing process on it to resoften that material. Resoften means we are going to increase the ductility, then machinability. We are going to increase the ductility, machinability, or we are going to make that material softer in nature. Then the next third objective is to here, this part already we have discussed. That is all properties here I have mentioned here to adjust its mechanical, physical, and chemical properties like hardness, tensile strength, ductility. Then here additional is to change their electrical and magnetic properties, to alter their microstructure, then to change their corrosion resistance. Also the heat treatment process is required. The next objective of performing this heat treatment process is to reduce or eliminate the internal residual stresses. Okay, whenever we are performing the some operations we have performed, or we have manufactured certain components, then there may be some internal stresses in that component. And whenever internal stresses are there in that component, during the actual use, it may get failed. Okay, it may get whenever load is applied on that component, and if suppose there are certain internal stresses in that component, then it will means it will lead to the brittle failure, premature and brittle failure of that component. That's why you have to eliminate, or you have to try to reduce the internal stresses which are present in that particular component. Okay. Then next, how this is conducted, that we are going to deal in the different heat treatment processes. Okay, this can be achieved in the annealing process. Okay, this can be achieved in the annealing process also. And whichever part we have seen here to alter this chemical properties like that, means we are changing its composition. That properties means we are going to do the surface hardening processes. That will come under this part. Okay, to change the chemical properties means we are changing the sometimes we are changing its composition. Physical properties or chemical properties can be changed by changing their composition also. Okay, changing their composition by introduction of the suppose carbon, nitrogen, silicon. Then their nature or their all properties will get affected. It means sometimes mechanical properties will get changed, sometimes physical properties will get changed, sometimes chemical properties will get changed, and that will come under the surface treatment processes. Okay. Then the fifth objective here is to induce controlled residual stresses. Here induce the control means we are creating some residual, we are creating some stresses in that component. Why to create the stresses? In the previous point we have seen here that we want to eliminate the stresses, and here I am telling you that you can create the stresses. Then why we are creating? Sometimes whenever that stresses are compressive in nature, whenever we are able to create compressive stresses in that component, it will increase the fatigue life of that component. Okay, it will increase the fatigue life of that component. As far as whichever stresses are present that are controlled and that are compressive in nature, it will increase the fatigue life also. Means you can use this heat treatment process to eliminate the internal residual stresses or to induce the controlled residual stresses to improve the fatigue life of that component. These are the objectives of the heat treatment process. The next objective is to stabilize the steel. Now, What is the stabilizing process here? Sometimes you have observed that whenever we are using any component or any material, suppose steel you have taken, then as time passes away, suppose after 1 year of the manufacturing or 2 year or 3 years, there will be certain changes in their dimensions. There will be certain changes will occur. Then to avoid these changes in the dimensions with the time, we are going to stabilize. We are going to do the stabilization of that steel. Okay, and this stabilization can be achieved by performing the different heat treatment processes. By performing different heat treatment processes only. Then heat treatment process can be applied to increase or decrease the grain size of the steel. Whichever steel is there, can improve its means you can either increase or either decrease its grain size. Whenever we are decreasing the grain size, the structure will become more fine and more uniform. Whenever more grain size is more, or we can say that coarse grains are there. Coarse means larger grains are there. Coarse means larger grains are there. Then it will result in the inferior mechanical properties. Their tensile strength will be less, or brittleness in that material will be more, and then we will be able to decrease its grain size. Fine crystal structure of fine grain size will be achieved. Then that material will provide you better tensile strength and better hardness. To achieve this means with, according to your need, you can either get the in larger grain size or smaller grain size, depending on your purpose or your applications required. You can do that with the help of heat treatment process. Then with the heat treatment process only, you can achieve the changes in the microstructure. Changes in the microstructures can be achieved, and as you are able to change the microstructures, automatically different properties like machinability, or you can say that their ductility, toughness, their hardness, their wear resistance, corrosion resistance, these all properties will revolve around these microstructure only. These all properties are based on their microstructures, means whichever phases are present in that microstructures, due to that only these all properties will vary. And with the help of these heat treatment processes, you can change the microstructures or phases existing in that particular material. You can change the phases present in that microstructure, and as phases will get changed, their properties will get changed. Okay, all these can be achieved with the help of the heat treatment processes only. Then the next objective of the heat treatment is to eliminate the gases. Okay, to eliminate the gases present in that particular material. Whenever gases will get entrapped in that, suppose in the steel, then what will happen? Embrittlement will take place in that steel. Then what is the embrittlement? Embrittlement means that decrease or elimination of the ductility from that particular material. Ductility will get completely eliminated, means that material will get transformed to a brittle material, and with a light shock it will get breaked, or it will fail with the light shock also, means due to entrapment of the gases. Like suppose here in this case of steel, hydrogen gas will get trapped, and the loss of ductility will be there for that steel material. It will lose its all ductility property, and it will become embrittle. Means embrittlement of steel will occur, and it will fail with the light shock also. To avoid this embrittlement of the steel, we have to eliminate these gases. We have to eliminate these gases. And how to eliminate these gases? By performing the heat treatment processes. Either we are simply doing the heat treatment process, and during that heat treatment process, these gases will get eliminated. Okay, particularly for this elimination of the hydrogen, just we are heating that steel component at higher temperature ranges, that is above 800 degrees Celsius, and that gases will get eliminated. And after that, we are cooling with the help of different cooling mediums to get the steel which is having better properties, better or required properties. Then the next objective in the heat treatment process here, here the last is the to change the composition of the surface only. Suppose you want to means certain components are there like gear. Okay, like gear you can say that. On the surface it will be subjected to the very high wear. Wear will be very high on the surface, and lots of load will act on that surface only. That's why we require very high hardness and wear resistance or corrosion resistance on that gear material on the surface. And how it is achieved? By increasing their hardness and wear resistance by changing the composition on the surface with addition of carbon, nitrogen, silicon, different elements are there. If you introduced that different elements on the surface, its compositions will get changed. Now, to how to change these compositions that we are going to discuss in detail in the surface treatment processes or surface hardening processes. Different surface hardening processes are there. If you are introducing the carbon, that will be carburizing process. If you are introducing the nitrogen on the surface of that steel, then it will be nitriding process. If you are introducing carbon and nitrogen both, it will be termed as carbonitriding process. All these processes, then how these processes are conducted, then what are their different cooling cycles, or how the heat treatment is done, sorry, how the heating cycle is selected, and how soaking cycle is selected, and how cooling cycle is performed. All these we are going to discuss in brief in this further our whichever part we are going to discuss, that we are going to discuss in the later part of our lectures. But here these are the objectives. In simple way, you can say that heat treatment processes, these are used, or what is the objective? To change the properties of the material. It may be their physical property, chemical property, or mechanical property, depending on our requirement or depending on our applications. That you can change their properties. That is the purpose of this heat treatment processes. Okay. Then, after discussing related what is the meaning of heat treatment process and what are the objectives of the heat treatment processes, the next part will be how this heat treatment process is conducted, or what are the different steps in the heat treatment processes. What are the different steps in the heat treatment processes? Okay, I will start it. Before that, let me confirm that all up to this it is clear. Shirsagar, are you there? Sachin Shirsagar.
Yes, yes, sir.
Okay. It is clear for you what is the meaning of heat treatment and what are its objectives.
Yes, sir. All clear.
Okay, okay. If you are having any difficulty, please ask me at that instant only so that it will get clear for you. Okay. As we are moving forward, all these
Okay,
basic
sir.
things will be used as a only steps. Okay. This heating cycle, it will be only a single point in that particular process annealing. Suppose the first point will be heating cycle, like that only point will be there. That's why you should get clear understanding what exactly happening in this, uh, so that if you are not getting any point, please ask me.
Okay, okay.
Okay, okay, anyone? It is very less. Okay, we will move towards the next point, that is the steps in the heat treatment process. As in the first point only, I have shown you one diagram. Uh, there only I have told you that the heat treatment process, it consists of, okay, okay, this is the diagram. Okay, whether it is clearly visible? Is it visible? This diagram is visible?
Yes.
Okay, if you are not able to see these values, okay, leave it. These values are not important here. Okay, forget these values. Just this curve should be visible for you. Is it visible?
Yes, sir.
Okay, then refer this curve only. Now, this heat treatment, any heat treatment process, it will consist of three cycles. First will be heating cycle, then second is the holding time or soaking time, or it is also known as holding cycle or soaking cycle, and the third process will be cooling cycle. Okay. Now here, the first cycle is the heating cycle. Now, this heating process means here we are taking the actual component and we are heating that component in the furnace. Sometimes you can directly heat it by keeping it in the furnace, or you can use the different mediums also. Now here, while performing the heating, the care should be taken in such a way that whichever heating will occur, it should be uniform, and heating should be performed with the lesser time possible. Means heating should be quick and uniform. Okay, that is the first point. Then why it is required to perform the uniform heating? That is the question will arise here, why it is necessary to perform the uniform heating. Then uniform heating is necessary to avoid the cracking and distortion in the components. Okay, sometimes if uniform heating is not there, then that component may get failed, or there may be some cracks, or there may be some distortion. Okay, to avoid that, uniform heating should be there, and some faster heating should be there. Okay, faster heating should be there to achieve the fine grain size. If you are not able to achieve the fine grain size, then what will happen? You will end up with the inferior properties. Means coarse grains or large sized grains will be there, and after cooling, you will get the large sized what you can say that the mixture of the perlite, or depending on that mixture of the martensite, perlite or bainite, different structures will be there. But just you have to remember here, this whichever structure you are obtaining, if fast heating is not performed, then you will end up with the core structure at that higher temperature, and due to this core structure, you will end up with the core structure at the end also, and due to that, its mechanical properties like tensile strength and hardness will be very less. Whichever required properties are there, that will not be achieved. Okay, that's why whichever heating you are performing, heating should be rapid and it should be uniform. Rapid to get the fine grain size, and it should be uniform to avoid the distortion and cracking. And whenever that heating temperature range is above 800 or above 850 degrees Celsius, then proper care should be taken that there should not be any decarbonization or oxidation. Decarbonization means loss of the carbon from that steel. That will be termed as decarbonization. And sometimes oxidation may occur. Some elements may get reacted with the oxygen, and they may result in the formation of different oxides at the higher temperatures. This should be avoided with the help of suitable mediums. Okay. Now, which heating mediums can be used different to achieve this? From room temperature to heat that steel component, suppose above 600 degrees Celsius, above 800 degrees Celsius, or above 1000 degrees Celsius. Here we require some heating element or heating medium. Now, this heating medium, you can perform this heating in the air also by using different elements. Then this heating can be performed in the oil also. Then this heating can be performed using the salt bath also. Okay, these three heating mediums will be there. Okay, I will come to the Okay, these are three mediums: air medium, oil medium, and salt bath. Heating of the component can be done using these three mediums. Okay. Then you can use either air medium, oil medium, and salt bath medium. Now, when you are using the air medium, here the air medium, when you are performing the heating in the air medium, then this heating will be non-uniform and this heating will be very slow. And as this is non-uniform heating and this is slow heating, here you are not able to get the fine grain sizes, and also there may be chances of some distortion and cracking, or sometimes here decarburization or oxidation will occur at the higher temperature ranges also. Okay, then if you are using this air medium, then you have to take the proper precautions to avoid all these oxidations, decarburization. You have to take the proper care. And which care you have to take here? You have to use the controlled atmosphere to perform the heating process. You have to use controlled atmosphere, like inert atmosphere. You have to use some inert gases. Okay. Then the second precautions you can take, whichever component we are going to heat, you can cover or wrapping of the component is done in the stainless steel foil, or whichever component on which you are going to perform the heating cycle, you can do the what you can do here, you can cover that component with the cast iron chips. Either do the wrapping of the component in the stainless steel foil or cover that component in the cast iron chips. Okay. Then here the third precautions you can take here, you can apply the thick coating on that component with the help of the boric acids. Okay. Or sometimes you can apply some different compounds are there which are termed as anti-scaling compounds, which will protect that component from the environmental conditions. Means it will get separated from, means that component does not come in contact with the air medium. In this way, oxidation and decarburization will be avoided. Okay. Just which one part you have to remember here, this air medium is slow and non-uniform, and chances of decarburization and oxidation are more in the air medium. Then the second is the oil medium. We can use the oil medium for heating. Here this oil medium heating is fast. Okay, it's fast and uniform. But what is the problem here? You will be not able to achieve the higher temperature ranges. Only up to 300 degrees Celsius, 200 to 300 degrees Celsius temperatures can be achieved with the help of oil medium. And for example, you can say that silicone oil is there, which will provide you 275 degrees Celsius temperature. Up to that, you can use the oil medium. Here, in short, oil medium is, it will helpful for doing the rapid and uniform heating, but higher temperatures cannot be achieved here. Then salt baths, uniform and rapid heating can be done with the help of salt baths. Then decarburization and oxidation also can be avoided in the salt baths. Salt baths means we are just using the mixture of the different salts. Okay, like KNO3, NaNO3, or you can say that sodium chloride, calcium chloride is again there, then barium chloride. Okay. Then potassium chlorides are also there, then sodium carbonate is there, and then these different compositions, these are used in the certain compositions depending on the temperature needed. For example, you can say that one examples, there is one chart that I will add in the next lecture also. I will show you that for your reference. I will tell you that suppose there is a mixture of sodium chloride and barium chloride is there. Okay, then it can provide you the temperature ranges of 700 degrees Celsius up to 1000 degrees Celsius also. Okay, barium chloride and sodium chloride. Here, large amount, more than 70% will be barium chloride, and remaining amount of the sodium chloride will be used. It can provide you temperatures above 700 degrees Celsius also. Then you can use the uh, sodium carbonate and potassium chloride. Sodium carbonate and potassium chloride. You can use it in the 50-50%, or it can vary from 45 to 55 for both. Okay. Sodium carbonate. If sodium carbonate is 45%, then 55% potassium chloride, like this. If 55% sodium carbonate is there, 45% potassium chloride will be there, like this. Different compositions you can use, that is the termed as the salt bath, and they will provide you the temperature ranges above 600, from 550 to 900 degrees Celsius range can be achieved with these salt baths. Okay, this is related to the heating cycle, then which are the different mediums that can be applied for this heating cycle. The next is the soaking time or holding time or soaking cycle. Here you can say that. Okay, this is the soaking time or holding time. In the first step, we are heating the component to a specific temperature, and after reaching that specific temperature, we are keeping the temperature constant, or we are holding that component at that constant temperature for a definite period of time. That will be termed as the soaking time or holding time. Then why to perform this soaking or holding process or soaking cycle? Why it is necessary? To get the, here first aim is to get the temperature should be uniform throughout the component. Okay, whichever component is there, temperature at the center of that component and temperature on the surface of that component, it should be same. Means temperature should be uniform. Okay, temperature should be, why temperature should be uniform? If temperature is uniform, all whichever carbide materials are present, it will get dissolved. Okay, it will get dissolved. Then second aim of performing this holding or soaking time or cycle is to get the uniform structure. Here our aim is to get the uniform austenite. Okay, to get the uniform austenite, only austenite phase should be there. Only austenite. In some exceptional heat treatment processes, in case of steels, there may be different phases, but here soaking time or soaking cycle or holding is performed to get the homogeneous phase, and that phase is austenite, and it is also termed as austenitizing process. Okay, holding for getting the homogeneous austenite. First aim to perform this holding or soaking cycle is to get the temperature should be uniform throughout, and second is phases should be uniform throughout, and that phase should be austenite. To get the homogeneous temperature and phases, this heating or soaking treatment is performed. Now in general, if suppose you have considered a component having suppose a square, you have considered 20 by 20 size square, then approximately it will take 20 minutes. Approximately it requires 20 minutes soaking time, and as shape and size of the component changes, this soaking time also change. Okay, the soaking time depends on the shape and size of that steel component, the type of that steel, then we suppose it is whether it is plain carbon steel or it is alloy steel. If alloy steel is there, then soaking time increases. If shape and size, if smaller size component is there, then soaking time also decreases. If larger size component is there, then soaking time will be more. Okay, in this way this process is conducted. Then after the soaking time, means after getting the uniform temperature throughout the component and uniform phase, that is austenite phase, means after getting the homogeneous austenite, this soaking process will be stopped, and that component is taken out from that furnace, and it is directly dipped into the cooling medium to cool it up to the room temperature. Okay, first is heating up to required temperature, then holding for a definite period of time to get the homogeneous structure and uniform temperature throughout that component, and after that it is cooled up to room temperature or below room temperature. Now to perform this cooling, different mediums can be used. Now to perform this cooling, here we can use the brine solution, cold water, this all are aware. I mean, just brine solution is different for you. Brine solution is nothing but cold water plus we are adding 5 or 10% will be salts like sodium chloride or calcium chloride salts will be there. Sodium chloride, calcium chloride, or sodium hydroxide salts will be there. Brine solution is nothing but mixture of cold water and 5 to 10% of the salts. Here you can use calcium chloride, sodium chloride, or sodium hydroxide salts. Next medium you can use for the cooling operation is the cooling cycle is cold water. The next is the water plus soluble oil, then only oils, then fused salts, only salts. Here different salt mixtures you can use. Okay, as we have discussed for heating also we are using different salt mixture. Here also you can use the different salts which will provide you the lesser amount of the temperatures. And last medium is the air medium, directly air cooling. Now whichever number I have provided here, these are arranged in the decreasing order of their cooling rate. Okay, first means highest cooling rate will be here for brine solution, or you can achieve the fastest cooling with the help of brine solution. Then cold water, then water plus oil, then oil, fused salt, and air. Air cooling is the slowest cooling, and brine solution cooling will be the fastest cooling. Then next is there are different steps which are involved in the cooling process. Okay, these are the steps. Whenever we are cooling one component in the cooling medium, these processes will take place. The first is the vapor blanket stage, second is the vapor transport stage, and third is the liquid cooling stage. Okay, when initially we have heated the component above 800 degrees Celsius. Suppose we are taking 800 degrees Celsius, then after performing heating at 800 degrees Celsius, holding there for definite period of time, we have taken that component and we have dipped directly into cold water or in the brine solution. Then the cooling, how the cooling will occur? Initially, when we directly dip the component from high temperature into the liquid medium, what will happen? That liquid medium will get vaporized, and it forms a blanket around that component. That blanket, this is the formation of vapor blanket stage, and due to formation of this blanket, here extraction of the heat does not occur. Okay, extraction of heat does not occur. As soon as you are taking the component from higher temperature ranges and cooling directly into the cold water, then vaporization of that liquid medium or cooling medium will occur, and formation of vapor blanket around the component will take place, and extraction of heat does not occur here. From that heated material, no extraction will occur here. Then in the next stage, whichever blanket is formed around that component, it will get break and it will directly come in contact with that liquid medium, and here extraction of the heat from the component will occur. That liquid will extract the heat from that heated component and cooling will take place. Here maximum rate of cooling is achieved. In vapor blanket stage, lowest rate will be there, um, or you can say that extraction does not occur there, and in the vapor transport stage, that blanket will get break, component will come in contact with the liquid medium, and here extraction of heat will take place. Then in the next stage, that is the liquid cooling stage, what will happen here? Temperature of the component reaches the boiling point of the cooling medium. Okay, temperature of the component reaches to the boiling point of the cooling medium, and in this stage, what will happen now? Here, the liquid is not able to extract the heat from that component. Here, heat removal only occurs due to the conduction and convection process. And here, heat removal rate is the lowest, or cooling is at the cooling rate will be the lowest here. In these three stages, whenever a hot component comes in contact with the liquid cooling medium, in these three stages, removal of heat will occur. First stage will be vapor blanket stage, second is the vapor transfer stage, and third is the liquid cooling stage. Okay, so in this way this heat treatment process will occur, and these three steps you have to follow in the steps you have to follow in the heat treatment process: heating cycle, then soaking time or holding time, and cooling cycle, and which are the different mediums used for heating and cooling that we have discussed in the brief here. Okay. In the next lecture, we will discuss related to the PTT diagram, CCT diagram, and after that we will start the actual heat treatment processes. After that we will start the actual heat treatment processes. Thank you for attending this lecture. We will continue this heat treatment of steel chapter in the next lectures also. Thank you.